Yeah, function f is continuous on the closed interval 2, 4. Maria, I read that, I think to myself, okay, that's good to know that the function's continuous. Whether or not I need that clue is kind of yet to be seen. Closed interval 2, 4. Probably not that important since all of them go from 2 to 4. This clue is important. So one of you volunteered to tell me, what am I supposed to be recognizing when I see that? What does that mean?
It's positive.
More
Like,
detail.
if it's positive, then it'd be actually increasing.
So you're remembering something that is important. Let me get it on the board here, actually. But you have to be a little bit careful. Just copy this over here. Same problem. Cool. Okay, so what you're remembering is that if the f prime function has positive y coordinates, then the function itself will be increasing. This is only the value of f prime at one point, however.
So is that because tangent slope?
Yeah, so what you said is true, but what is more important to remember for this problem is this is telling you that the tangent slope of f, when x has a value of 3, that tangent slope's value is going to be 2. That's probably a much more important statement. There's just the three of you, so we're working this problem, but as you're listening, if something pops to mind, just jump right in. How about this clue? Want to get a comment on that?
Not it.
Yeah, thank you. It's kind of early in the morning.
Yeah. Well, the second derivative f has all the negative values, so the graph of f would have to be concave.
Perfect. The other thing I always notice when I see that, Maria, is not every problem, but I don't know, some of them are going to ask me to remember as well that as I look at my graph that's concave down, so for example, if I were to extend this down a little bit, and draw a concave down curve, if I go from tangent to tangent on this curve, this tangent slope is positive, this one is less positive, then even less positive. That's partly what the D represents, is that as you follow the curve of f, you go from tangent to tangent to tangent, the values of those tangent slopes decrease. So I want to remember that.
So is that just that for mainly for f of prime?
Yes, so the D in this column means two things. One meaning is, if you're looking at the graph of f prime, you would see a graph with y coordinates that go down.
Okay.
But if you're looking at the graph of f, you have to look at tangent slopes point by point, and you'll see tangent slopes whose values go down. Like this might be a tangent slope of 10, and this would be maybe 8. Maybe this is 5, something like that.
Okay.
So the D has both meanings, and you've got to make sure you have that memorized so that when you see Danica's chart, which you have memorized, that thought just comes to mind again. So, and again, that's why if you're struggling to remember, if you're struggling to have these thoughts come to mind, the only way to fix it really is to make flashcards and then go through the flashcards daily until the thoughts just come to mind. Like there just is not another way to do it. You can practice and practice and practice, but until you put in the work to commit the thought to memory with flashcards or some other method, you'll just keep staring at problems and going, I don't know what to
What would be
do.
great for this one then?
So for this one, I think I would build a flashcard that says this. Think for a second. Let's say if F is, so try to make my flashcard short. We'll say concave down, concave up's just the opposite. If F is concave down, then I have dot, dot, dot. The tangent slopes, comma, point by point, comma, will decrease in value. So this should say the tangent slopes of F, sorry. And then I put in parentheses secants 2. So back to here. Okay, so I've pretty much read everything there is to read. I've decoded the clues. Now I'm hoping that with those flashcard memories, I'll think of something to do. So anybody have an idea? Please bring it.
Would you take the y values on some of them, just like the difference between them?
So we do want to do that, but we don't want to do it unless we know why we're doing it. So why?
It's because, like, f prime, the tangent slope, it's gonna be like slowly, like, increasing less and less. So the difference would be like less between them. or less than-
Now you're on the right track. When you're finding the difference between, say, these two y values, what you're really doing is you're comparing the difference here with the difference here. So this difference is easy, that's just 1. This difference is 2.5. This difference is 1.5. So what you're really calculating is a secant slope between x equal 2 and x equal 3. And that secant slope's value is 2.5 over 1. And then this next secant slope is 1.5 over 1. Then you can do the same thing for all of these. You end up with a secant slope of, let's see, 2.5 over 1, and 2 over 1. Howdy, welcome. Then we have 2 over 1, 1.5 over 1, 1.5 over 1, 2.5 over 1, etc. These are 2 over 1 and 2 over 1. So doing the computation is easy. That doesn't help you to remember that. You've got to remember why you're doing it. So we're finding secant slopes for each of these possible functions of f. So somebody explain how that connects to the other things in the problem.
Well, f of prime, we're trying to find f of prime, which equals 2 at 3. So the first one is 2.5, 1.5. We know it's like going to be in between them or something like that because it's concave, decrease or something like that, right?
Right idea. Somebody just fill in the details. Like in the
So
morning
is
talk
it
about
because like it wouldn't be like a because it's 2 between 2 and 3, and so or 2.5, and so it's supposed to be 3.
No, so the big idea here is we're supposed to have a curve that is concave down.
Okay.
And we're supposed to Welcome, Maya. A lot of drink there.
Yeah. They're really thirsty.
So we're supposed to have a curve that is concave down, and concave down, just like we wrote on the flashcard, means that if you go from tangent to tangent, you see a decreasing pattern. But if you go from secant to secant, you also see a decreasing pattern. And if you go from tangent to secant to tangent to secant, you still see a decreasing pattern. So what we've done is we've said, okay, I can go from here to here. That's the first 2 points in my table. And I can calculate the secant slope. And I can jump to the next point, calculate a different secant slope. So this one, this secant slope turns out to be, at least for table, the first table, we get a secant slope here of 2.5. That's between points x equal 2. This is 2 comma 2.5. This one's at 3 comma 5. And we have secant slope of 1.5 here. This point is 4 comma 6.5. So that fits the pattern that you have to have if the curve's really going to be concave down. From secant to secant, you must have a decreasing pattern. Welcome, Dylan and Whitney. Question. So now what do we do?
Since like 3 is not, like the secant slopes aren't like increasing, so it wouldn't be positive down.
Perfect. No, it's exactly what you're supposed to be able to recognize. Yeah, it's the whole idea of the flashcards again, that when you recall Danica's chart, you remember the D, you remember the flashcard that says, hey, curve is concave down, so my secant slopes, the secant slopes of F, point by point, have to decrease. And then as Ashley said, that is not happening with D. The secant slopes are not decreasing, so D cannot be the answer.
And E is concave.
E appears to be concave up based on the data we have, so that doesn't work either. So now what?
This is where I got stuck.
Yeah, same.
So back to the flashcard memory. For those who walked in before I started talking about the flashcards, what I was saying is Preston made a very common comment. I've heard it year after year after year, which is when we do them together, they make sense. You don't really have any questions. Everything seems clear. But then later, when you try to do some new problem, you just tend to stare at it, and your brain doesn't recall anything. And what I said was, okay, the only way I know how to fix that is through work. Like, there's just not a magic method. The work involves, and that's why I put these on here. You're welcome to take as many as you want. That box in the back corner is completely full of flashcards, so we're not going to run out. I would make flashcards. Every time you're hitting a problem, you're saying, I don't even know what to do. It's because there's some fact that we have discussed in class that just is not coming to mind. And in flashcards, the only way to get those facts to come to mind.
Joking, I don't know what
You're good.
The facts are just random. They're all over.
So,
Can't remember.
and they are kind of random in the sense that, again, you're just very accustomed to practice problems, redo same problems.
Yeah, I'm used to
Yeah.
like, here's all the rules, now go do the homework.
Right.
It's like easy, you know?
And I like
You got it.
Same, it makes sense.
So we're just trying to convert your brain to a more useful mode.
Yes.
So anyway, so I would have this flashcard. it says if a function is concave down, then the tangent slopes or the secant slopes, you might want to add this to the flashcard. So secants, the other one would be secant, tangent, tangent 2. So the idea is that if you alternate, like I go from, welcome Josh. So I go secant slope of 2.5, and right at 3 I have a tangent slope that is precisely equal to 2. Right at 3 I have a tangent slope that is precisely equal to 2.
Is that because, oh, what is that?
So with the picture, 1 second, sorry, it's going to look like this. This slope is 2.
That's what it was saying when it, when F prime of 3 equals the tangent slope. It's talking about this tangent slopes. So that.
Correct. No, it's perfect, Maria. So all of these tables fit this picture. They're supposed to fit this picture. You have a secant slope between the first 2 points, and we calculated those different secant slopes, 2.5, 2.5, and 2. We know these 2 don't work. We calculate the second secant slope, 1.5, 2, and 1.5. They told us that the slope, the tangent slope right precisely in the middle is supposed to be just 2. Well, this table works really nice. It does exactly what you would expect. Secant slope, then tangent slope, then secant, nice decreasing pattern. This one doesn't. This has got to be between these 2. If the curve's going to be concave down. This has to be between those 2 if the curve's going to be concave down. Otherwise the curve, between the 2 secants. That's what the flashcard is trying to remind you of. And when a curve, so basically what they're testing you on, Abby, is a thorough understanding of what it means for a curve to be concave down. For a curve to be concave down, you have to be able to view the curve, go from a secant slope to a tangent slope to a secant, and see a decreasing sequence. And the only one that works is table A.
So this is, no, I know this is probably a dumb question.
It's not.
Everyone else.
No, it's
It
not.
might be.
I promise.
So a secant slope is the one where it's the dot to dot, right?
Right, just the slope
Okay.
between 2 points.
Okay, but what does that have to do with basically, how does that?
Good question. Good question.
So the idea is that if you have some sort of function, the function is changing. The values here are not the same as the values here.
Okay.
Slope is a measure of how the rate at which the values change. Secant slope is an average rate of change, meaning that on average, how do the values change from here to here? For example, we've got x equal 2, y equal 2.5. We move along the function, we get to 3, 5. Well, between those 2 points, the input changed by 1, the output changed by 2.5. So we say on average, the output is changing by 2.5 every time the input changes by 1. So a secant slope is an average rate of change. A tangent slope is an instantaneous rate of change, like how fast the function is changing right at the point. Now, I wouldn't make flashcards for that at this, like I don't think you need to know that yet. The key thing right now is just to know that secant slope means slope between points, tangent slope means slope at a point. That's crucial. You have to know that.
Tangent slope is the what? Is the slope at?
So it's the slope at a single point, or the rate of change at a single point.
I love him, but he sucks at teachers. Just expects me to know.
Oh, yeah.
Like,
Anybody needs flashcards, here's some more
I don't
flashcards. Thank you.
Limit exists, yeah, and if the protein that serves the protein that's in the spot, both sides, does that make sense?
So, what?
Do you remember?
Yeah, I remember like you have to like two tests before.
Questions
Yeah,
there,
it's like-
Josh? Different one.
Which one's? If you guys got over number 5, and there's protein
So
We
that's
did, but we can look at it again, that's okay.
6. Protein that.
Most weren't here when we went over 5.